My name is Tom Brent. I'm with Sol Ark, and what we're going to do is I'm going to briefly talk about the Sol Ark 8K, but really my goal here is to educate you on the different ways we can wire it, how we can program it very easily, and some of the different setups, whether it's grid tie, whether it's and without batteries, or whether it's grid tie with battery backup for our critical loads. There's also some new capabilities where we're actually not getting a net meter agreement, and we're just limiting all the power to the home use, and we can use our batteries at nighttime. So we'll look at that. We'll also look at some of the web monitoring tools because they're really powerful. And we'll look at 3 different customer examples. You know, a grid tie example, a limited home and time of use solution, and then also an off-grid with a generator. Then we'll get into some of the advanced setups where we look at off-grid, where we're using smart loads and reducing our battery sizes. We'll look at generators, large and small, and how to hook those up. We'll look at AC coupling because we support both DC and AC coupling on the system. And then we'll also look at PV rapid shutdown. So with that, and by the way, if you have a question, please use the messages. Okay, here we go. So just a real brief introduction, and our goal here is to reduce the cost of solar plus storage. And we do that in a very large way with multiple solutions. One is we're a DC transformerless design, which is very efficient, but not all DC transformerless designs are as efficient as we are. If you need, most of them are geared for the grid only, and they do batteries as an afterthought, so they're not very efficient. And we focused our last webinar on that a couple weeks ago, and that's on YouTube. But what we do is we are so efficient that we're able to use 10 to 20% less solar panels than competitors, and that was covered again 2 weeks ago. And that, if we're talking about a 10 kW system, that's about $3,000 installed. We also reduced the storage inverter cost by about 30%, which is a sizable amount. Then we also improved the battery efficiency in a couple different ways. When we get to the battery comparison, some batteries are much more efficient, have much larger round-trip efficiencies than others. We'll see that lithium and carbon AGMs have a much higher round-trip efficiency than the traditional wet cells. So that can reduce our solar array by 10 to 15 or more %. That's a big deal. We'll also, we focus on improving the install time and reducing the amount of support required. It's an all-in-one system that supports 11 kW of solar, large inverter so you don't have to stack, and has a nice wiring area with breakers already installed. As we'll look today, there's a lot of powerful remote diagnostic tools so that we don't fly over all around the country to support our customers and debug a feature or miss setting. We can also utilize existing solar systems. So that allows us to use that AC couple into that existing solar, and then add some DC solar with it to get up to 13 kW of PV. The last is we improve battery capacity by 10 to 20% depending upon if it's off-grid or on-grid. We use features like smart loading and time shifting of loads to enable us to use solar power instead of using battery power, so we don't need such a large battery, and that helps reduce our cost. The other thing is you don't need UPSs around your household or your businesses. So we're being installed in PC server rooms for customers, and anyway, you don't need these UPSs. We have a very fast transfer time of 2 milliseconds, the fastest in the industry. So you basically get a giant UPS. And that's why we're being installed in banks as well as businesses for light commercial use. And that leads us to the last thing, which is because we're doing both residential and light commercial, in less than a month we will support 120/208 three-phase, so that we can do have a single inverter support some of the businesses and commercial market. Okay, so this is just a brief overview of what we support right now. It's basically an 8 kW inverter, 20 kW peak, and we support up to 500 volts. There are built-in MPPTs, and we support. There's 2 MPPTs with up to 2 strings each, so we can have 4 strings and support up to 11 kW of solar. We have 50 amp breakers to support 12 kW of pass-through, and it's a very efficient design. As I mentioned a little bit earlier, batteries are optional, so we can add batteries later. We can use this as a grid tie inverter to start with, and as the customer's budget allows, add batteries after the fact. Something we do is EMP hardening for some of our systems. Some customers need that or want that, and 5-year warranty with 10-year optional. So let me just cover the key things. This is the system, the user wiring area, battery connections, solar panels, and wiring, but we're going to get all into this. So I guess, let's see, we'll talk about the battery temperature sensors, auto gen start, rapid shutdown, external, yeah, we're going to cover all this. Okay? All right, so here's the very basics of the system. If we look at the, first, the system computers, they can use, there's 3 different power sources, and it can use any of those 3 power sources for the computer systems to stay alive. This was built for redundancy, to survive a lot of different scenarios. So there's a PV shutoff down below the system that turns on and off the solar panel inputs. There is also a grid input that can handle 240 or 208. And there is a front on-off button, which basically turns on and off some of the battery power. But if I have any one of these 3 sources of power or multiples of these power, the computers will stay on and the screen can still be used. This is important for debug if you have a wiring mistake or something is not done correctly. So if I want to fully power down the system, I have to turn off all 3 sources. The main button here turns, not only does it turn on the battery connection, but it also turns on the inverter. So if I can leave some of these other pieces connected and hit this one on-off button, and the system will shut down except for the screen and the computers. But the load outputs will not be live. As far as the screen goes, we have a couple different LED indicators on the top here. There is a DC, which stands for PV input. This will be not lit at nighttime or if the PV shutoff is off. The AC light, which is basically the grid or a generator if I'm off-grid. And the normal light, which says the inverter is turned on and it's working. And then we have these direction indicators. The escape key will get us to the home screen, and up and down, we'll use some of those for programming, and then the enter button or the OK button. Okay, so I'm going to go through a few screens here for you, and if there are any questions, please feel free to ask. Okay, so we tried to make this really easy for the homeowner to understand. So you'll see how much the solar is producing. Remember, this is a color touchscreen display. So, and we'll go through some of the screens. This is how much solar it's producing, 6.4 kW. We also tried to have some green to red so that you had some sort of indicators, how close we're pushing the system. We can push up to 8.4 kW on the solar, or in production. Let's see, and if I could ask, please mute yourself unless you have a question or if you want to ask via the chat. So in this case, we're selling back to the grid and we're running a few loads. Let me change the setup here. Okay. All right, that's better. All right, so in this case, we're producing 6.4 kilowatts, and then we see that that power is being distributed in two different ways. It's going back to the grid, and it's also going to our loads. And our batteries are full, so we don't need to really put any power in that. So this always tells you what's going on in the system. And this is a simultaneous hybrid or transfer switch. So I can use any amount of power from batteries or any amount of power from the grid and any amount of power, well, whatever the solar is producing to power my loads or power the battery and so forth. So it's very easy. It's nice. If I touch the battery icon, it gives me this detailed screen that installers like and some engineers like. It tells me instantly what's going on in the system. This is just the home screen, the overview for the customer. Okay, so a customer asked, would the smart load be added to total loads or have a different icon? The smart load is included in this load icon, so its power is included in that. And we'll cover smart loads a little bit later. So here I can see what's going on in the solar. This is total, this is MPPT1, the voltage, the amps and the watts, and then MPPT2. Then here I have what's going on in the grid. And by the way, I should say here, if you're getting a 0 volts, maybe your plus and minus leads on the solar panel connections are backwards. It won't hurt anything, but you'll see 0 here. The grid connections here, it's minus because we're selling back to the grid. And likewise, if we're putting power into the battery, it's going to be a minus. Putting power out is plus. So here I can see that I'm on, this is L1 or line 1. Don't worry about the home right now. The load is, this LD stands for how much power is coming out at the connection of the AC grid breaker on the AK system. This home is a home sensor that is actually on the main breaker panel for the customer. We'll look at the limited home mode in a little bit. So anyway, we can see this is L2, again, what it's pushing back. I should say each MPPT can support up to 4.8 kilowatts, and so we can have an unbalanced type of system. It doesn't care. All right. Okay. As far as the inverter, this is what the inverter is doing on L1 and L2. And then here, it looks like we have an unbalanced load, so that's why we're selling back less here, and we're selling back more here because of this imbalance in the load versus the inverter. The inverter is putting out an even load. Okay, but anyway, here's what we use this screen for is just debug, very easily seeing what are the loads on L1 and L2, as well as how much the inverter power is, how much the battery power is, whether the system is warm or not. If the temperature sensor is not connected, you'll get minus 20, battery voltage, battery percentage, and so forth. Okay, so this is just some of the basics of the screens. Again, if we touch the solar icon, then we will get the solar power being produced. And these up arrow and down arrows represent the keypads, so you can see previous days. And these tools are built into the system, so I don't need external connections for this. Also, I can see how much power is being produced per month if I hit this, and this is basically on a per day basis for that month. And then if I hit the grid icon, I can see how much has been sold back and how much my loads are and so forth. So this helps me with load planning. So if we're going to do grid tie and sell back, then you can see here we're just taking the power in and we're putting it back on the grid. There's really no battery used, so you're not going to really see a battery or a load. It's as simple as connecting up the solar panels, connecting up to the grid, and it's just going to sell back. So it's just like a grid tie inverter in this case. Don't need batteries, and it's just going to sell back. And we'll look into how that's set up. As far as the PV is concerned, The PV can be anywhere from 150 to 500 volts. That means we can do 10 60 cells or 8 to 9 72 cells or maybe 5 to 6 96 cell panels. Do not go above 500 volts. If you go above 550, then that means damage will occur to the system. We can do 9 amps per string, 18 amps per MPPT, and we really don't have to worry about it. It's self-limiting, so if we go a little over, it's not going to be a big deal, but please don't try and exceed 11 kilowatts because that is an issue. Can this have zero export without a battery? Yes, it can. Zero net export is what we call limited home mode, and we'll get into that. So I don't need a battery for that. What is the significance of the color on the arrows on the screen? Oh, that's a good question. The colors on the screen, just green is producing power. There's really not a big deal about the screen colors. It's just to show whether it's going in or out. That's all. Nothing important about that, really. And then will the three-phase version have L1, L2, and L3? No, it has L1 and L2 only. We don't support true all three phases. We support two out of the three phases, and so we do L1 and L2, and they're 120 degrees out of phase. Okay. Okay, with that, on the strings, like I said, we can go up to 10 solar panels, anywhere from 5 to 10, depending upon how many cells there are. And typically, so we have 2 MPPT controllers. So we need, there are 2 inputs per MPPT, so we may need to balance out the number of panels if we're putting them on the same MPPT controller. So it still gives us a lot of versatility. All right. So how we set up the grid tie system, first we will click on this little settings icon, and there it brings up the setup menu. And in the setup menu, I have a few different things. I've got my software versions, is my SD card, which stores all the data in there. The first thing that comes up that you should notice is what's the day and the time. You know, please always set the day and time for these things. It can be a little bit tricky with the AM PM thing because it's a little small, but please set the right time for the systems. And then this is whether the Wi-Fi is connected or not. So we've got basic setups, which is things like the display. We should leave auto dim on because the screen backlight will not last if it's on for years and years. So I recommend that you leave the auto dim on. Okay, what happens if it exceed 11 kW in solar? It will self-limit, but we want to keep it within 11 kW. Please don't exceed too much more of that because we're not going to necessarily honor the warranty if you're going to go 12 and a whole bunch more. Okay, we're getting to some advanced questions like the gen sets and transfer switches. Let's talk about that when we get into the generator setup. So this is just grid tie. There's no batteries, there's no nothing. It's just simple. So here, a basic setup is, again, the display and, setting up the time and date. And then we'll look at battery setup later and grid setup and some alarms. Okay, so in addition to the grid tie setup, what we want to do is we want to select no battery. If we don't select no battery, the default is battery percent. It will beep at you if you turn it on. Again, you can power up the system with the grid or with solar and be able to program this thing. You don't have to turn on the on button. So anyway, if it expects a battery and you put no battery there, then it's going to beep at you. Although you can silence the beeps by just going to the basic setup and unclicking beep and click OK. I should mention that you need to press where the text is, not where the button, this is. Sorry, I didn't write the software. And then if you need to increment or decrement something, you can hold down the up and down arrow keys. You don't have to keep pressing it and wearing your finger out. Okay, so we'll select no battery. UL 1741 is the default under grid parameters, grid setup, and then normally it's limited power to load for safety, so we'll select grid cell and click OK. We have to click OK in every tab setting because it's a safety feature. We want to make sure that you wanted to program it that way exactly. And that is basically how we set it up for grid tie setup. It's very, very simple. Not a lot to it. Okay, so if we want to add batteries to the system, then what we'll do is we still have the grid section here. We still have the solar panels connected, but all we do is we add batteries, and then we also add a battery temp sensor if so desired. There's a battery temp sensor here. By the way, it says plus and minus, but there is no polarity on the temp sensor. And then we'll see batteries, either battery voltage or battery percentage here. And then we'll have a critical loads panel or a 10-circuit transfer switch on our load output. This is our UPS output. And there's a little bit of programming involved with this. So this is going to run on grid and power those loads. Oh, notice that this is 12 kW pass-through. So that's how much our loads in our grid can be. The inverter can only do 8. So the basic things besides what we just talked about for grid setup, the setting up the time, is we want to set the battery capacity and we want to set the max charge and discharge amps. So I typically do about 20% of the battery capacity. I like battery percent charge more than voltage because customers understand it better. I'll go to the charge, I'll click OK, and then I'll go back in here and I'll look under the charge tab. And, so this max charge amps here is how much the PV array will charge the batteries. This is the master charge value, so it doesn't overly charge your batteries in terms of too fast. Then I can charge it off the grid as well. And this is really for generators, so we'll get to that later. But when I'm on the grid, if I've got this charged, it will always try and keep the batteries full, unless I'm doing some other special features. I will also set my float and absorption and equalization values if so desired, and depending upon what battery type I'm using. And then I'll set the discharge, but usually these defaults are pretty good. So let's see. So what this is doing is this says I will indicate a low battery at 35% SOC, and the battery icon turns yellow, and then it'll shut down the inverter, but keep the PV charge circuits on at 20% full. And then once the batteries get back up to 50%, it will restart the inverter output. This says, can you equalize over 60 volts for a flooded battery? We cannot. I think for some of the flooded batteries, we would need to do a little bit. You might need an external equalizer to do some of that. Okay, so limited home with time of use. So this setup was just a grid tie with battery setup. So we're just using these batteries as a backup for when the grid goes down, and it'll be automatic when it does. Okay. So here we're doing more than just running these critical loads off of solar. What we're going to do is we're going to actually do much more. We're going to actually sell back to the house. And this is called limited home mode or zero net export. And what we do is we add these sensors on the mains of the whole house, L1 and L2, and we provide the sensors, and they get wired into limit 2, limit 1, and they need to be correct. And so what we'll see is the solar will be producing and we'll be running our loads, but then it'll be selling back to the rest of the house to cancel out like a big air conditioner in the house or some other loads. And so it's pretty similar. Okay. Could you explain BMS lithium battery? Okay. Good question. Someone asked about lithium batteries. Good point. If we're using lithium batteries, we may want to use some of these. If there's no communication on the lithium battery, then we just use the battery voltage, usually battery voltage, sometimes battery percentage. But if we have a communication bus, like a CAN bus or RS-485 bus, which we have connections for right here, you can see those here, and there's also Ethernet connections here. So if I'm going to communicate to a lithium bus that has a communication bus, I will turn this on, and sometimes I need to activate the battery to turn it on as well. But that way I'm able to read back the SOC and the temperature from the battery. That's all it's mainly used for. If I'm not able to communicate to the battery, let's say I accidentally turned this BMS, this battery, lithium battery on, you will see an exclamation point here. That something's weird with the battery. So also if your voltage of your batteries is too high, it'll give you an exclamation point. Okay, so here's where we're talking about we will program limited power to home, and what this will do again is sell back to the rest of the house. I've got my loads here. Here's an example. I've got my loads here consuming about 2 kilowatts, and the inverter is actually pushing back to the rest of the household about 1.6 because it's trying to cancel out some other loads. So we'll see here at the inverter side basically about minus 1.6 kilowatts, but here's our home sensors are reading about somewhere between 0 and 30 watts. So it is canceling out the entire home grid. And that way we don't need a net meter agreement with the utility company, and we're able to consume all the PV that we're able to consume the PV, and then if we enable time of use, what this will do is it will allow the batteries, when the PV is not producing, it will allow the batteries to feed the loads and the whole house, and let it drain to whatever percentage you program in here, depending on your battery technology. So here we just set it up for 50%, let's say, and we'll use the batteries at nighttime to zero our home meter, and then daytime it'll use the PV, and at nighttime it'll use this, and the grid is basically a backup. If we have some time zones where we can use, where we get cheap electricity, we can charge the batteries back up. Let's say maybe I want to charge them to 100% or 80%, and I can enable grid charge. So, so anyway, this is all user programmable. Allows us to do whatever we want to at given times, and we have quite a few customers using it because that's the way we're headed, where we're not necessarily doing all grid sell because they won't buy it back for a very, very large amount. Okay. So here, sometimes, I should say here, sometimes it can be tricky to get these sensors installed correctly on L1 and L2 and have they're directional, so they need to be in the right direction. They need to be in the right sockets. So when I'm limited to the loads, I will see basically I see the loads here, and my load sensors I'm not exporting out of the 8K system itself, but I can still see a positive value for home. That means my home is consuming some more power. So that's limited load mode. If I do limited home mode, I expect to see some negatives at the 8K point of viewing, and I expect to see near zero at the home. So that's the difference. And if I'm selling back to the grid, I expect to see negative. Well, I don't need the home sensors, but I expect to see negatives all throughout here. Okay, so I had some examples. I don't know if I'll try and get back to some examples of some of the features here, and let me see if I can do that. Okay. Okay, so So we use what's called Shine Monitor. Okay, there's a question, is there a limit to distance for the sensor wires? We say probably 50 to 100 feet is probably good. They may be a little bit slow in responding. It can be better if you use shielded cable. Okay, can a 400-watt wind with internal regulator be tied to the batteries? Yes, you can do that. You can have a separate wind system going directly to the batteries. Okay, so let's take a look. So if I want to look at power generation, I open up this and I can look at power generation. I can see how much power I'm producing at over given days. Okay, so this helps me understand how much power I'm generating over a given day. Okay, there's your standard curve, standard bell curve. But what the real interesting data is when I go to device management. So let's go to, typically you will only have one here, and I can look at the data curves, and I can see, let's see, a couple different things. I can see the active output power. So here we've got a somewhat cloudy day, so we're going up and down in power. This is how much power the system is putting out, and this is a grid tie system. Okay, and let's see here. I'm going to show you a little bit more here. This is the detailed data. So what this does, this tells me a whole bunch of stuff. This gets tracked every 5 minutes, so this is very, very useful for debugging a problem because it gets timestamped. So I can see how much power I've generated in one day. I can see how much power I'm generating at that time. Active output power from there. Let's see a couple of the parameters here. Temperatures. Okay, I can see what my PV voltages are, if you can see that. Okay, this is my PV MPPT1 voltage and current, MPPT2 voltage and current. I can tell whether I have grid voltage present or not. So anyway, I can tell where the inverter's putting out. I can tell what it's measuring in different places. Anyway, I just want to give you an idea of what we can track. We can track the loads. This is a very, very useful tool for debug in avoiding, having to go out to a customer site. We can see the battery voltage, battery percentage, all these types of things. We can see this. Also, we can see how they program the system. Okay, so a very useful tool. There's too much to go into here, but I just wanted to point that out. Oh, can I blow that screen up? Ooh. Well, sorry. You mean this is about as big as I can make it? Okay. All right. Okay. So good feedback. So anyway, this was a grid tie system. Now let's take a look at another system where we're using okay, I'm going to go back to a couple of different places here. Okay, so what I'm wanting to see here is this is a zero time of use, or I should say limited home mode. And what we're seeing here is we're trying to zero out the meter. Actually, let me see which day I wanted to do this in. 2/12 was a good day for solar. Okay, yeah. So here we had a good solar day. We can see that once the sun came out, this is the grid external total power. So this is what you're seeing at the meter. And we're seeing that we're zeroing the meter. for the most of the time. And then here we had a spike in power, and we had to pull a little bit from the grid. But we're not selling back anything to the grid. We're just consuming. And then we started using the grid power again later on. So that's what we're seeing here. If we want to see some other things, we can look at battery output power. So here we were charging the batteries off a PV, and then we started using battery power once the sun went down. And we can see actually here a positive. We can see here that the battery power was actually forcing 5 kilowatts. They're probably turning on some very, very large appliance like a well pump or some small heater or something. Anyway, and that's what those spikes are doing. And then we used a lot of battery power to power the rest of the household. And then we reached a certain battery percentage, so we can see that. This is battery percent. So we were full for most of the day. Then we started using battery power, and it started falling off until it fell off a bunch. And then I guess they programmed this to stop, to only discharge the batteries to 70%. A question: how far back will the information log stay available? If you have it plugged in, it keeps years of data. So it's a very useful tool. Even if you're off-grid, this is very helpful for debug. Especially because we want to be able to see what the battery percentage is in terms of SOC. We want to be able to see what the battery voltage is. You can see here that it's 57 volts, and then we've got some peaks and valleys, and then it just stays stationary. So this is limited power to home with time of use, because we're using the batteries to use that up. How would you set the discharge on the PCC batteries? I would use about 50% depth of discharge. Okay, so the remaining situation is very, very interesting. So in this scenario, this customer is this customer is totally off grid, and they are charging the batteries here, and then they're using the batteries here. You probably got some heater, but this is an interesting customer in that they're off grid and they only have 10 kilowatts of battery power. So they have very large swings. We can see here that at the nighttime, their batteries just kept draining until it got down to about 61%, and then it started charging off the solar. And then if we look at their battery voltage isn't changing much because they're using a lithium battery, and the battery is very, very constant and consistent. Let's take a look at one particular day. Let's go back to this day. Here, what we can do is we can see the grid side voltage, L1 and L2. So if I'm off grid, I am using a generator through the grid side voltage. And you can see here, they turned on a generator they have an auto gen start, so it turned on for about 4 hours to recharge the batteries. And we can actually see that the batteries got down to a certain level, it kicked on the generator, and then started recharging the batteries and left the generator off. So that's a useful tool. And then here's battery voltage. As you can see, lithium doesn't change very much. But I just wanted to show you some of those nuances and show you how capable this system, the debug tools are. Okay, so with that, I want to move back on to the presentation. Okay. All right. So in terms of an off-grid setup, we would actually put the generator into the grid input, and we would. So we're not normally running the grid or the generator, so we're going to have a yellow icon here, and let's see here. We would also use this gen start connection. This is a normally open, and it closes this relay when we need to start the generator. Will we have access to the debug tools? Yes, everyone has access to the debug tools. They're free. And we can also create some logins for installers to see some of their customers. as part of that. Just ask us. In addition, we also have, so our generator is coming in the grid side. That frees up this generator input, but this can also be used as an output. It's called, we use it for smart load. So we can run some very high powered appliances off the generator out, or this smart load output. Okay, so if we're setting this up for off-grid, we need to very carefully set this start percentage or start voltage, because that is when it's going to turn on this gen start relay. Again, because our generator is hooked into the grid breaker, we're going to actually use grid charging, not generator charging. That's a different input. Okay, we can't use the smart load and gen charge. It won't allow you to select both at the same time. It's one or the other. In addition, we'll use limited power to load because our load is the whole house, as this shows here. Okay, so this is our off-grid setup, and we will want to also select some general limitations. You know, we want to widen. The reason why we're selecting this is we don't want to use UL 1741. It's very, very tight in the frequency range. So we want to use some wide frequency parameters to allow us to go from 55 to 65 hertz so that it'll work with any generators. And that's part of this. In addition, we'll enable the smart load, and that's where we enable this smart load, turn this on, and what it'll do is it'll wait for the batteries to get to 100%, although these are fully programmable, you can use percent or voltage, and we will turn on the smart load at 100% and turn off the smart load at 95% full. You'll see the main screen show smart, saying the smart load is on, and if I was off grid, I would probably program this to 0. Because this is more used for time of use. This actually turns on the smart load when we're connected to the grid, and it waits until the power gets up to this, the PV power gets up to this to turn on the smart loads. It's for really time shifting. But I would turn it to 0 for off grid, because if I want to turn on my generator, I want my smart load to turn on too, because I'm hooked up to a generator. And I forgot to mention here that as our loads go up in terms of this loading here from the generator, it will decrease the charging value so that we're not overloading our generator or our grid breaker. So it's pretty smart. So a couple things here. If I'm off, like I said, if I'm off grid, maybe my batteries aren't at 100%. And I need to actually turn on my water heater or my heat pump. I can actually hold this icon down for 2 seconds. It will force the smart load to come on for about 4 hours, and it'll automatically go back to its cycle. So that's something that's built into. Okay, let's see, on grid. So here's where we would use that generator input for a small portable generator, is if I'm connected to the grid, and this is on grid, that's where this would be the easiest connection. I'm not going to be able to use the smart load here, but I can enable this gen charge and have different charge values for my small generator and so forth. Okay. Okay. Someone asked for a long press. If I want to force, if let's say my batteries are below where the smart load will turn on, let's say my battery bank is down around 90%. So instead of changing the programming settings here, I can just press or hold this icon, this load icon. It will force the smart load on. And then 4 hours later, it will automatically go back to its normal cycle. That's what that question was about. Okay, rapid shutdown. This is coming up more frequently. What we do is we have a rapid shutdown connection here that supplies 12 volts to a transmitter. And that transmitter goes on the positive line and goes to the receivers. They can either be a per string shutdown or a per panel shutdown. But I don't want to get into those. What we basically do is we put in the negative side. Oh, I'm sorry, the negative side to the rapid shutdown transmitter, and the positive side goes to a rapid shutdown button out externally, and then comes back and loops back into the Sol Ark. So I can either hit this rapid shutdown button externally, and it will shut down the PV array, or I can turn off the on-off button on the system, and it will also shut down the transmitter. Okay. Grid tie with battery and AC coupling. So here, here what we're doing is we want to use this generator for something different now. We want to AC couple as well as DC couple. So we can take a string inverter and put it into the generator port, and we enable this microinverter input. And what we do is we program on. We want the system to come on at, let's say, 80% or below SOC values. Actually, let me rephrase that. If the grid is up, then this will just be a pass-through. The string inverter will simply go to the grid and also the power produced from the 8K. If we're off-grid, what this will do is we need to swap these. We need to have a lower value for turning it on, so we'll turn on this connection to the string inverter at about 80% SOC or below, and then it will shut off the connection internally at about 95% or higher. And that allows us to use this in a totally off-grid situation where we can AC couple and DC couple. We can do up to 13 kilowatts of solar, and we just have some balancing that we have to do. We can do up to 7 kilowatts of AC and up to 10 or 11 kilowatts of DC. So that's up to you. What charge controller technology are you using? What charge controller technology? We use a string inverter so we support up to 4 strings. They're 500 volts MPPTs for our string inverters built in. This string inverter is just for AC coupling. Okay. Okay. Another question is that used for AC coupled battery or only another inverter? Only for another inverter. We are the AC coupled battery in this case. So this is an AC coupled inverter along with our AC coupled system. Okay. Is our firmware and software optimized for lithium batteries? Yes. We can do a lot of different things. We can go down to 41 volts and do a lot of stuff with lithium batteries as well. That's not an issue. All of this is programmable. Okay, so I guess on-grid with portable generator. I guess the one thing I didn't cover was the where we use a generator on the main input here. I don't see that slide. Nope. Or did I cover it? Yeah, I guess I missed that. Okay, so anyway, we can put a large generator can go directly into this, and we can use our automatic gen start. So there's no problem with us selling back to the grid and using like a big standby generator here on the grid, and that frees up this connection. Okay, so that covers a lot of this, and somebody asked, could I hook up this system to a power wall to it? I don't need a power wall. This is a power wall, and it's half the price of a power wall, so I wouldn't use a power wall. You could do 3 kilowatts AC from microinverters and 10 kilowatts DC for a total of 13 kW. Yes, you could do that. That's what we'd recommend. So that is kind of a summary. I tried to go through it as fast as I can. I apologize. I have to reboot my computer before I start this due to Windows, I guess. But we will do a whole thing on batteries, and I hope you're able to join us then. I guarantee you won't have any glitches. So what is the max kilowatts for gen input through the smart load? Oh, it's a 40 amp breaker, so we could do, what's 40 amps? We can do 8 kilowatts, which is how fast we can charge the battery. So you can do any size generator through the smart load. Can this inverter be connected to a 3-phase 208 system? Yes, it can be connected to a 3-phase 208 system. Well, which part? We only connect up to L1 and L2, so only 2 of the 3 phases. This isn't a true 3-phase warranty. How much is the extended 10-year warranty? It is $1,000 extra. So anyway, I hope this was valuable, but anyway, I really appreciate you guys attending. Any questions, please feel free to reach out to us, and we'll cover that. Back to AC coupling. Can we have multiple Sol Arks in one location? Absolutely. I think maybe if the question is, can we have multiple Sol Arks feed the same loads? No, we don't combine loads. That's not available. We have to. Do we offer an AppSep credit? No. I guess we'd have to qualify that area. We'll be at the NAPSEP conference. How field serviceable is the inverter? Oh, it's not bad. Although we haven't had to do too much field servicing, the front cover can come off, and you can get to the fan. You know, later on down the road, you may have, 10 years from now or 15 years from now, you may need to change the fans, or you may need to change the LCD screen, or something of that nature. A lot of the boards and those things are field serviceable, so that's not an issue. If we only use 2 phases to connect this to a 3-phase system, do we have to connect the 3rd phase of the 3-phase system to some load to balance the system? No. We have 2. Our system can handle just 2 phases. They're independent of each other. Can multiple inverters use the same generator supply? Yes. You can have one generator go to multiple inverters. Okay. Well, anyway, a lot of people still on the line. I appreciate that. I hope can the warranty be increased from 10 years? Is that your question? It's a 10-year. Yeah. Oh. Well, no. 10 years is our limit. Yeah. Buy 2. And save 1 for later. I don't know. Anyway, no. 10 years is our limit. That doesn't necessarily mean it's not going to last a lot longer. It's a 20 kW inverter. We're pushing at 8K. It's pretty robust. Okay. Well, anyway, I want to thank everybody for their time, and if you have a question, please feel free to reach out to us. And again, I apologize for the hiccup on the system. My computer I need a newer computer. All right. Take care, everyone. Bye-bye.